Imagine a science teacher telling her class that there might be a hidden giant lurking at the edge of the solar system, a world roughly 10 times more massive than Earth that no one has ever seen. She compares it to living in a house all your life and suddenly learning there's a massive secret room you never knew existed. What makes this possibility even wilder is that this unseen world seems to tug on the other planets from afar, like a ghost moving objects in a room. Stick around to hear why astronomers are nearly obsessed with finding this phantom planet, and tap that like button so more people can join our journey. Growing up in the 1990s, a young student memorized 9 planets, from Mercury out to Pluto, only to watch as astronomers knocked Pluto off the list, leaving 8. Yet, recent evidence hints there could be a 9th after all. This hypothetical Planet 9 sits so far away that it would take light more than 3.5 days to reach it. In neighborhood terms, if the solar system were a small town, this planet's house would be like a property halfway across the country. The story began in the early 2000s, when astronomers, led by Mike Brown and Konstantin Batygin at Caltech, noticed something odd in the orbits of several distant, icy bodies beyond Neptune. The objects seemed to gather in one corner of the sky, almost like marbles on a table, moving towards the same edge. This pattern didn't fit any known gravitational influence. Brown had already discovered Sedna, a dwarf planet with an exceptionally elongated orbit, and his colleague Chad Trujillo later helped identify 2012 VP-113. Both objects seemed to be pulled into their paths by something heavy. The question became, what kind of unseen force could corral these scattered worlds into formation? Keep listening as we venture into the outer darkness and unravel the clues. Picture a game of pool, where instead of your cue stick sending balls into pockets, invisible hands guide several balls to the same corner. That's what astronomers observed when they plotted the orbits of bodies like Sedna, 2012, VP-113, and a handful of other trans-Neptunian objects. These rebels follow elongated paths that all point roughly in the same direction. One astrophotographer likened it to walking across fresh snow and spotting a series of footprints converging at one point without seeing who made them. Among these bodies, Sedna completes a lap around the Sun every 11,000 years and never comes closer than about 76 astronomical units, AU, more than twice the distance of Neptune. 2012 VP-113's closest approach is about 80 AU. The chance that 6 such orbits line up by pure accident is less than 1%, meaning something must be organizing them. Astronomers tried explaining the pattern with Neptune's gravity or with random clustering, but simulations kept pointing to a different culprit, a massive body far beyond Neptune acting like a shepherd. The evidence suggests this shepherd exerts enough pull to reshape orbits over millions of years. But why would these distant snowballs flock together? The answer, according to Brown and Batygin's modeling, is a big unseen planet with a mass 5 to 10 times that of Earth and an orbit roughly 400 to 800 AU away. Their calculations showed that a planet of that size would naturally corral the rebels into the observed arrangement, much like a magnet aligning iron filings on paper. As more observations rolled in, the pattern persisted, strengthening the case for Planet 9. To understand how something invisible could organize these tiny worlds, think of a shepherd dog guiding sheep. Even if the dog hides behind a hill, the sheep's behavior betrays its presence. Planet 9 acts as a gravitational shepherd, slowly nudging objects into similar orbits. The idea may sound fanciful, but gravity is a force that works over astronomical distances. One historian recalled how Neptune itself was found in the 19th century. Astronomers noticed Uranus wobbling and inferred that another planet had to be tugging on it. They calculated where this unseen world ought to be, pointed their telescopes, and there was Neptune. Similarly, Brown and Batygin used simulations to test thousands of scenarios. Only those with a super-Earth-sized planet in a tilted, elongated orbit produce the observed clustering. In their model, Planet 9 takes between 10 and 20,000 years to complete one orbit and travels 20 times farther from the Sun than Neptune does. Its orbit is inclined by 15 to 25 degrees relative to the plane of the other planets, meaning it rides at a different angle, like a tilted ring around the Sun. This misalignment could even explain why the Sun's equatorial plane is tilted 6 degrees compared to the orbits of the planets. Caltech's Alessandro Morbidelli noted that over billions of years, the gravitational influence of a massive planet with a skewed orbit would gradually torque the rest of the system, accounting for the Sun's 6-degree tilt. That's a small but significant lean, like putting a heavy book on one corner of a dinner table and watching the whole surface slant. When you consider that the entire solar system could be slowly wobbling because of a hidden planet, the mystery deepens. Now imagine placing a heavy weight at one end of a seesaw. Everything tilts ever so slightly. Planet 9, if real, could be that weight. Caltech researchers propose that a body 10 times Earth's mass, orbiting far from the Sun, would exert a torque over billions of years, gradually tilting the whole solar system. Evidence of this tilt comes from the fact that the Sun's rotation axis is about 6 degrees off from the plane in which the planets orbit. Most star systems we observe have their stars and planets aligned, so our slight tilt stands out. It's as if the cosmic dinner table is slightly off-kilter, and Planet 9 is the culprit pressing down on one side. Another parallel comes from history. Before telescopes confirmed Neptune, astronomers predicted its existence based on irregularities in Uranus's orbit. The same method is being applied now to the outer solar system. Brown, Batygin, and others continue to refine the planet's possible path, estimating that it may be closer than originally thought and have an orbital period of about 7,400 years instead of 18,500. This recalculation improves the chances of finding it because it means the planet would reflect more sunlight and move faster across the sky. Yet, despite improved estimates, the planet remains hidden. That brings us to the search. Hunting for Planet 9 is like searching for a person dressed in black inside a vast, dark cave with only a dim torch. The object lies hundreds of astronomical units away, so faint that it barely reflects sunlight. At that distance, even a planet several times Earth's size would appear as a slow, dim dot among billions of stars. Observers with the 8.2-meter Subaru telescope in Hawaii have scanned the region predicted by Brown and Batygin, but they only get a few nights per year to dedicate to the hunt. NASA's Transiting Exoplanet Survey satellite, which scans for exoplanets around other stars, might incidentally capture the faint motion of Planet 9, but it is not designed for such slow, distant objects. The best hope lies with the Vera C. Rubin Observatory, set to begin full operation soon, this 8.4-meter telescope will photograph the entire visible sky every few nights, creating a time-lapse of the heavens. Astronomers anticipate that its deep, wide surveys will reveal countless new objects, including faint, slow-moving points that match Planet 9's predicted signature. The Rubin Observatory's legacy, Survey of Space and Time, LSST, aims to find more objects in the solar system in its first year than have been found in the last century. As it repeatedly images the sky, software will compare frames and flag any objects that drift slightly from one photograph to the next. If Planet 9 is out there, this survey could catch it hiding among the stars. Yet even with such technology, not everyone agrees the planet exists, which leads to an intriguing possibility. What if the shepherd is something altogether different? Some theorists propose that the mysterious gravity could come from a primordial black hole, a tiny, ancient black hole left over from the early universe. Researchers Jakob Schultz and James Unwin suggested that Planet 9 could actually be such a black hole weighing 5 to 10 Earth masses, but compressed into a sphere only about the size of a bowling ball. They were inspired after learning about microlensing events, bright flashes observed when compact objects pass in front of distant stars, bending their light. Their study argues that a small population of primordial black holes with the right masses could explain both the unusual orbits of the trans-Neptunian objects and certain microlensing observations. Other possibilities include a cluster of smaller bodies working together, like a swarm of bees exerting a combined pull, or even the effects of dark matter halo structures we don't fully understand. There are also skeptics who think the clustering results from observational bias. We see what we expect to see because surveys look in certain directions. The debate itself highlights how much there is left to learn about the outer solar system. Whether the culprit is a planet, a black hole, or a bias in the data, the mystery demonstrates the limits of our knowledge and the excitement of discovery. So, does Planet 9 exist? The honest answer is, we don't know yet, and that uncertainty is thrilling. We stand on the edge of discovery, much like astronomers did before Neptune's detection. A hidden world 10 times the mass of Earth may be gently tilting our solar system and gathering distant icy bodies into formation. It could even be a primordial black hole, a relic of cosmic history. The search challenges our technology and our imagination. For the first time in human history, we have the instruments and the data to unveil an object in our own cosmic backyard that has eluded us for millennia. One can only imagine the excitement of the scientists who will first glimpse that faint dot moving against the background stars, a new member of the solar family or perhaps something entirely unexpected. If this story fascinated you, give this video a thumbs up so others can find it too. Jump into the comments and tell us whether you think Planet 9 is a super Earth, a tiny black hole, or just a trick of the data. And don't forget to subscribe and share the video with mates who love space mysteries. Your curiosity drives us to keep exploring the universe together. Let's see what we uncover next.